A detailed explanation of magnetic field examples. The magnetic field of an object is associated with both magnitude as well as direction, hence it is considered a vector quantity. The magnetic field created on the material can attract or repel another magnetic material or charge. The magnetic field produced on the material may be permanent or temporary. Some of such permanent and temporary magnetic field examples are explained below. The magnetic field between two bar magnets. Suppose you place two bar magnets together so that the north pole of one bar magnet faces the south pole of another bar magnet, that a magnetic field is created between the two bar magnets so that they are attracted to each other. Even if you place like poles together, magnetic fields are generated around them so that they repel. Magnetized iron piece. Iron pieces are good magnetizable materials so that they can be magnetized permanently or temporarily by magnetic induction. When the iron pieces are magnetized by means of magnetic induction, the magnetic fields are generated around the iron piece. Thus, magnetized iron pieces are excellent magnetic field examples. Compass. For navigation purposes, mariners use a compass to detect the direction. The compass has a magnetic needle that creates the magnetic field around the compass so that the south pole of the magnetic needle compass directs towards the north pole of the Earth and vice versa, such that the direction can easily be determined. Hence, magnetic needle provided in the compasses is excellent magnetic field examples. Moving charges. Moving charges are responsible for the creation of a magnetic field in an object. Since moving charges carries the magnetic field, they can be considered magnetic field examples. When the charges are under motion, spinning and orbiting of the charges around the nucleus take place such that rotation of magnetic lines of force around the particle is created, and thus magnetic fields are produced by the moving charges. Paper pieces and comb. During school days, every student has experimented with combing the hair continuously and then holding the comb near the paper pieces. The paper pieces stick to the comb, which illustrates the electrostatic force. The sticking of paper pieces to the comb is due to the comb attaining temporary magnetism, and paper pieces are attracted to them. The magnetic field is generated around the comb and the paper pieces so that paper pieces are stuck to the comb. Though it is an example of electrostatic forces, the mechanism illustrates the generation of the magnetic field. Electronic devices. All the electronic devices work on the electromagnetic principle. For the efficient functioning of electronic devices, both electric and magnetic field contributes equally. The electronic devices consist of either permanent magnets or electromagnets. Once they are turned on, the magnetic fields conduct electric current to flow through the device. Since the magnetic field is one of the reasons for working electronic devices, it can be considered a magnetic field examples. Solenoid. The solenoid is a long coil of wire with many turns which is used for the conversion of electric current, and it acts as a switch. When current is passed through the turns of the solenoid, uniform magnetic fields are generated, which helps to convert electric current to mechanical work. The solenoid generates a controlled magnetic field by means of electric current, thus, it is regarded as an electromagnet. The production of the magnetic field in the solenoid is similar to the bar magnets. Thus, solenoids stand as very good magnetic field examples. Current in the wire. The current in a wire consists of moving charges which indeed carry a magnetic field. It is the simplest magnetic field examples. The charges in the wire move to produce the magnetic field inside the wire, which generates an electric current in the wire. Wire loop. The wire loop is the source of the magnetic field. Wire carries the current which intended to produce magnetic field inside the loop along the loop axis of the wire. This magnetic field, S direction, is associated with the right-hand rule. All the fingers except the thumb are curled, which indicates the current in the wire loop, while the thumb represents the direction of the magnetic field. Human body. The human body has a weaker magnetic field. Since we know that the human body carries current in very small amounts, the magnetic field arises due to the small current which consists of moving charges. MRI scanners. MRI, magnetic resonance imaging, is a medical device used to detect damage in the human body. An MRI device is a big magnet that produces magnetic fields of around 3 Tesla. MRI scanners use static magnetic fields, which are 1,000,000 times greater than the normal magnetic fields we are exposed to in our day-to-day life. Even though the magnetic fields in the MRI are powerful, it does affect the human body, hence they are installed to examine the human body to detect the damage. Earth's magnetic field. Our Earth itself consists of a large magnetic field that extends from the core out of space. Our Earth has many core, among them one of the core is rich in iron and nickel. When this iron and nickel core is rotated, convectional currents are produced which carries the charged particles to produce magnetic field. The magnetic field of the Earth creates a shield for the Earth which serves the Earth by protecting it from the harmful radiations from space. The Earth's magnetic field is strong at both the poles, and it seems to be weak at the equator. The magnetic field of planets. All the planets in the solar system have a magnetic field that shields them as a magnetosphere and protects the planet from harmful radiation and solar wind except Mercury, Mars, and Venus. The magnetic field of Jupiter, Saturn, Uranus, and Neptune are much greater than the Earth. A study on Mars says that once the Mars have a magnetic field, but the generation of geodynamo by the inner core iron in the Mars shut down 1,000,000 years ago, and hence it does not have its local magnetic field. The magnetic field of the Sun and stars. Stars consist of plasma. The motion of conductive plasma inside the star generates the magnetic field of stars, simply called a stellar magnetic field. The generation of the localized magnetic field is exerted on the plasma, and hence the pressure is increased without increasing the density so that the magnetized region rises and reaches the photosphere of the stars. The Sun is a giant star that has its local magnetic field due to the rise and fall of hot gases in the interior core. The strength of the magnetic field of stars and Sun weakens as the rotation slows down. Many solar activities are influenced by the flip of the magnetic field at the poles. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.